Hey everyone, in this video we're just going to go through how to do this worksheet on solving trig equations using graphs. So most of these eventually you won't use a graph for, you will just use your exact values, but I just wanted to go through how to use graphs for you to get an understanding of why you have multiple solutions for x, okay? And what we've got here are two sine graphs. Now, the main difference between the two of them, actually, let's just get rid of this. Okay, so the main difference between the two is just the scale. It's the same graph. All right, you can just see your x scale is different. And then we've got our cosine graphs. Okay, so we're going to be using them to help us find or solve these equations, find x. All right, so let's start off with question number 1. So the domain is just what we call our x values. So for the first one, we're only going from 0 to 2 pi, and these are all sine graphs. So I'm just going to go to my sine graphs. All right, so these first two here, and we're only looking at this part of our graph. All right, so our x values from 0 to 2 pi. All right, so not on the other side. We're only looking here. All right, so the first question. All right, so the first question is asking us to find sine x equals y. Now, if I were to graph that, that's just y equals sine x. So all I've graphed is sine x, the graph of sine x. All right, we're used to seeing graphs like y equals mx plus c, which is a linear graph. Or we can have a parabola, which we haven't done the graphs of, so let me just not draw that one. So we've got y equals. So for these questions, our y is equal to 1. So going back up to our graphs. All right, so let's go back up to our sine graphs. And here is y equals 1. So y is equal to 1 everywhere along that line. And I'm crossing my curve here and here, but we're only looking at the yellow section. So we're ignoring this solution over here and only looking at this first solution. Now I can see if I go down, all right, so going down, we want the corresponding x value, because remember we're solving for x. I am halfway between pi on 3 and 2 pi on 3. Okay, so somewhere between pi on 3 and 2 pi on 3. Now, if you don't know what that is, you can just change your scale. So let's do this value here. So halfway between 0 and pi on 3 is pi on 6. And then we've got, here is 2 pi on 6. And then that must mean this one here is 3 pi on 6. And this one here is 4 pi on 6, and so on. All right, so I can just change my scale to be pi on 6. So this point here is 3 pi on 6, which is the same as pi on 2. So my answer for the first one is, let me just rub out what I had there before, is just pi on 2. Now, if you wanted to check your answer, you can just do sine of pi on 2. So sine of pi on 2, just make sure we're in radians, which we are. So this button here changes it to radians, and we should get the answer of 1. Whoops, I flicked back to degrees. There we go, and there's your 1. All right. Then we just do the same for the others. So if I look at sine x equals 0, so this time I'm looking at the line when y equals 0, so where it's crossing the axes. So it's crossing here, 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 here. We're only looking at the yellow section, so I might just highlight the solutions. All right, so we're looking at this solution, and this solution. So it's at 0. All right, so our first one is 0, then pi, then 2 pi. 0, oops, wrong one. The next one down. 0, pi, and 2 pi. All right, so just looking at the next one, doing the same thing for cos. And in question 3, this time we're just extending that domain. So instead of going from 0 to 2 pi, we're going from negative pi to 2 pi. All right, so let's have a look at let's do a cos one. So let's do cos x equals a half. All right, so we go to our cos graphs. All right, so there they are there. So remember, we're looking at cos x equals a half. So we'll just draw a line at y equals a half. All right, so there it is. You can see it going through half there. We only want to go from negative pi. So here's negative pi. So I'm starting here and we're going all the way to 2 pi. So we're looking at that section there. So wherever that purple curve crosses the black line at y equals, so there, there, and there, they're our solutions. And you can see, all right, there's 1, clearly on our scale. There's 2, and there's 3. So negative pi on 3, pi on 3, and 5 pi on 3. So let's just put that down. So negative pi on 3, pi on 3, and 5 pi on 3. Now some of them would be quite hard to see. So if I was to do the next one up, so cos x equals negative root 2 on 2, you might actually have to put that onto your calculator. So negative root 2 sometimes it's a bit temperamental. Come on. All right, and we can see it's negative 0.71 approximately. So, sorry, just press that too many times. All right, so we're looking, what were we doing? Cos or sine? I think it was cos, wasn't it? All right, so we go to our cos graphs. There they are. We're doing negative 0.71, so we're going to be kind of roughly here, probably a little bit over. Might redo that actually. Oh, you know what? It's probably good enough. All right, so you can see it's crossing our graph here, here, and here. So if I went up, I can't clearly see what it's hitting. So let's do the same thing on our graph below. So negative 7. And remember, our domain is going from negative pi. So I'm just going to highlight that in purple. All right, and think about where it's hit the graph. So it's hitting here, here, and here, like we said before. But this time you can clearly see where it's hitting on your x-axis. So that's why I've given you 2 graphs. All right, so negative 3 pi on 4, 3 pi on 4, and 5 pi on 4. All right, let's have a look at the one above it. So negative root 3 on 2. All right, so we get negative 0.866. So let's just say it's close to somewhere halfway between 0.8 and 0.9. Oops, sorry guys. Did the same thing before. All right, so we're looking at the sine graph this time. All right, let's have a look at the second one because it hasn't got anything written on it. So I'm just going to highlight, we're going from negative pi to 2 pi. And I'm just going to draw the line going through negative 0.866. 0.6. So 0.6, 0.7, 0.8. So we're kind of halfway between. All right, so again, it's difficult to see. All right, so I can't see it clearly on that scale. So let's do the one above. So since I'm using the one above, I'm just going to erase what I had here. And highlight. So we're going from negative pi to 2 pi. All right, and let's just go through it again. So 6, 0.6, 0.7, 0.8. So we're kind of here. And I can see now that it's clearly crossing those grid lines. So we've got here, 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 and here. So my solutions, negative 2 pi on 3, pi on 3, 4 pi on 3, 5 pi on 3. So negative 2, negative 1, 4, 5. Okay, so all you need to do is look at those values off your graphs. Now, eventually we'll get to the point where we'll just use the unit circle, but I want you to try to have a go at understanding how to see them from your graph. All right, let's have a look now at question 4. So question 3 is similar to question 4. We're just working in degrees, but you can stick to radians. So we're going from 0 to 2 pi. Okay, so first of all, going from 0 to 2 pi, so that's important to note, and they're written slightly different. Okay, so I've got root 2 cos x minus 1. So all you need to do is rearrange that equation. So root 2 times cos x minus 1 equals 0. You need to get the cos x on its own. So the first thing I'm going to do is add 1 to both sides. So they'd go. So we've got root 2 cos x, whoops, equals 1. And then remember, I want to get the cos x on its own, so I can divide both sides by root 2. So that goes. So cos x is equal to 1 on root 2. Now we are used to seeing that as root 2 on 2 because we would go ahead and then rationalize the denominator. You don't need to, but you do need to recognize that they're the same thing. So root 2 on 2. All right, so doing that on the calculator. So let's just say you left it as 1 on root 2. So 1 on square root of 2. All right, so 0.71. And then you would just do the same thing as before. So we're doing this question here. So we're finding cos. Let's just go back up. I might just quickly delete what I've got there. All right, so first of all, we're only looking at solutions from 0 to 2 pi. So we're going down to here. And then we're looking at 0.7, so 0.6, 0.7, so kind of here. And you'll see that it kind of goes through the grid line. Okay, so it goes through the grid line there and there. So if we follow down, we've got pi on 4 and 7 pi on 4. All right, so for 4c, just continuing that answer, x is equal to, trying to remember, pi on 4 and 7 pi on 4. All right, so for question 4 and some of the questions in question 3, you do need to rearrange them. So they're either cos x or sin x. All right, so that's that worksheet. I do want to just now show you how we'll eventually do it using the unit circle, just in case you're interested. And this is where you need to know your exact values. So I might just have a look at 5a just quickly to show you. So cos x is equal to -1 on root 2. Now we always look for our reference angle. Okay, so that means we're either going to have an answer that is pi on 4, pi on 3, or pi on 6. Okay, so one of them. This is where you need to know your exact values. So I purposely chose this one because I know what 1 on root 2 is. Remember, that is the same as negative root 2 on 2. So if we were to solve that, we would get x is equal to pi on 4. All right, so that's our reference angle. Now, with my unit circle, all right, so once we've got our reference angle, it doesn't matter whether it's negative or positive just for the time being. We use our unit circle to determine where cos, because remember it's cos, is, and it's negative. So cos is negative in quadrant 2. All right, so it's negative here, and it's also negative in the third quadrant. All right, because sine is only positive in the second quadrant, and tan is positive in the third quadrant. So we're only looking at those two quadrants there. So here is 0, here is pi, and 2 pi. So remember, we always go from the horizontal. All right, the question does say going from negative pi to pi, but let's just change it to go from 0 to 2 pi, just to make it a little bit easier. So we're only going from 0 to 2 pi for now. Later on, we'll look at different domains. Okay, so pi on 4. So here's pi on 4. All right, but it's positive in that quadrant. So pi on 4 is not actually one of our solutions. Our first solution is this one here, okay, which is pi minus pi on 4. Now, if you have trouble doing that, you can just make them have the same denominator. All right, so pi is the same as 4 pi on 4. So 4 pi on 4 minus pi on 4 gives us 3 pi on 4. So there's one solution. Our other solution is in this quadrant. So remember, with the unit circles you created, I said you're always going from the horizontal. So that solution is pi plus pi on 4. And again, if you wanted to change it to have the same denominator, so we get 5 pi on 4. Okay, so that's how you will eventually do it, just with your unit circle, not with your graph. So if we were to, I think we did one similar before, didn't we? So yeah. So here is exactly the same question. We just had a bigger domain, so that's why we had the negative 3 pi on 4. But we got then just the 3 pi on 4 and 5 pi on 4 because we started at 0. But eventually you'll be using your unit circle like that. But for the time being, I just want you to get used to thinking about, well, those number of solutions on your graph. Okay.